Okay, good morning, everybody. My name's Matthew Harris. I'm the Technical and Quality Manager for SOCOTEC Asbestos. And thank you for joining me this morning for this webinar on the future of asbestos air monitoring. Now, you may well be wondering what I'm going to talk about. So just to kind of give you a sort of heads up, the future of asbestos air monitoring, our aims this morning are to highlight the recent changes following the release of the Health and Safety Executive's new HSG 248 Analyst Guide associated with asbestos air monitoring, and how we can perhaps achieve lower air test results when undertaking high volume sampling with our standard current techniques to help demonstrate best practice. So let me just start off by a quick overview. So the presentation will be around about 30 minutes, and then there's an opportunity to ask questions, which I can hopefully answer either through the chat as we go through the presentation or at the end with a Q&A. So if you're sitting comfortably with a coffee, etc., I'll make a start. So to start off with then, this morning, I'm going to cover sort of three kind of broad areas. I'm going to focus first of all on legislation and legal requirements and the current guide. So a real quick kind of recap on legislation. I'm then going to talk about current air monitoring and fibre sampling techniques using phase contrast microscopy. This is the standard technique we use in the UK, and then a slant towards an introduction towards high volume air sampling, and where we can use these techniques maybe in the future, what kind of scenarios that we can take high volume samples on to aid our best practice in terms of managing asbestos risk. And then we'll wrap up with a summary on what the future may hold. So let's dive straight in then to legislation. It's always good to start a webinar with a legislation slide. We'll get that one out of the way right at the start. But here we go. So as we're all well aware, if we work in the asbestos industry, asbestos management, that the UK is heavily regulated in terms of asbestos regulations. The key piece of regulation being the Control of Asbestos Regs 2012. Now, these regulations have been about, again, in many forms for many decades. We're well used to the management of asbestos here in the UK. Now, the prime kind of aim of these regulations is to reduce the risk of exposure to individuals and thereby reduce the risk of potential ill health in the future. These regulations are supported by the approved code of practice, the ACOP L143. And when we take in the regulations, the key ones I want to focus on initially are obviously regulation 4, duty to manage, and the requirement to undertake asbestos surveys in buildings to identify asbestos materials so they can be managed and the risk of any potential exposure reduced within buildings on a daily and ongoing basis. You're then supported by regulation 5, the identification of asbestos. Again, this regulation really drives reduction of exposure during refurbishment projects, demolition works, etc. It's all about finding that hidden asbestos within buildings and identifying it before the works take place so it can be removed safely. And then another regulation that you may not be so familiar with is regulation 16. And this is the duty to prevent the spread of asbestos. And there's a clear duty in the regs to obviously prevent the spread of asbestos so that we're not exposing people within occupied buildings. This goes for both asbestos removal and the general kind of occupation of buildings on a day-by-day basis. Now, these regulations are supported by obviously air test limits that are quoted in the regs and the approved code of practice. And the two I wanted to mention first of all are the 4-hour control limit, which is set at 0.1 fibres per centimetre cubed. And this control limit is the level at which, if work on asbestos is going to be undertaken and it's going to exceed this limit, then an approved Health and Safety Executive asbestos contractor must be used to undertake the works. And then we have the clearance indicator. This is set at 0.01 fibres per centimetre cubed. And this is the limit that is deemed an acceptable limit to reoccupy buildings after asbestos removal. And this level has also been used historically through asbestos management as an acceptable limit to occupy buildings generally that contain asbestos. And this is kind of a standard level that asbestos analysts will monitor to when they undertake air fibre sampling. So as we move on in terms of legislation, looking at the approved code of practice next. So again, I've mentioned the clearance indicator 0.01 fibres per centimetre cubed. That sounds a very small number and very low. And what I like to try and think of is that I can't really imagine a centimetre cubed of air. But if I was to have a metre cubed of air above my head, i.e. 1 metre in each direction as a cube, that would equate to 10,000 fibres. What we're saying in effect is that the clearance indicator is acceptable if there's less than 10,000 fibres in that cubic metre. Now, when we go on to read the approved code of practice, there's a clear statement there in paragraph 453 that states that this clearance indicator of 0.01 fibres per centimetre cube should only be taken as a transient indication of site cleanliness. Again, in conjunction with the thorough visual that's undertaken during asbestos removal, and that this level is not an acceptable permanent environmental level. That posed the question then, is that why are we monitoring at 0.01 in the first place? Again, to answer that question partly, there is no environmental limit in legislation. So therefore, we cannot monitor down to zero, for example. Again, we all acknowledge that with asbestos, there is no safe limit. And of course, the guidance from Health and Safety Executive that we should reduce our exposure to as far as reasonably practicable to as low as possible. But what is, as far as reasonably practicable? Is it 0.01 or is it 0? Now, back in the 1990s, the Medical Research Council undertook research in buildings that contain asbestos, typically the more high-risk types of material, and they identified, in effect, kind of background levels within buildings that contain asbestos that's well managed, well controlled, and in good condition, fibre levels down to 305 to 302. Again, clearly significantly lower than the standard clearance indicator of 0.1. So we asked the question, why are we not monitoring down to these lower levels? And I'll answer that question a bit later when we actually look at our fibre techniques, etc. Again, going back to the regulations, Regulation 4, there's a duty for the duty holder to manage risk to prevent harm to anyone who occupies that building in terms of asbestos risk. So therefore, how do we define harm if there's no safe limit of exposure? I would argue that there's a limit somewhere between 0.01 and 0.005 or 0.002 that would be perhaps best practice if we were aiming towards the lower levels in buildings for fibre monitoring on air tests. Let me now just quickly recap some of the improvements in the new guidance. So HSG 248, the analyst guide, was in draft for many, many years and was finally published last year. One of the key kind of changes to that document was the inclusion of different analytical techniques. And these analytical techniques typically included fibre discrimination. And what I mean by that is that there are techniques that can actually identify asbestos fibres on air samples. These techniques are typically lab-based, and they are things like SEM, which is scanning electron microscopes, or using TEM, transmission electron microscopes. These are big pieces of analytical equipment that sit in laboratories and can detect and count those asbestos fibres. Whereas our current and long-standing technique, phase contrast microscopy, PCM, this technique typically is a total fibre count. Okay, so we have a current technique that counts all fibres, but the new guide does bring in fibre discrimination using other techniques. But one step forward in terms of PCM monitoring is the introduction of what we call high volume sampling. So the guide brought in a new sample type called far source sampling, whereby we are monitoring away from a source of asbestos. And typically the easiest example will be a contaminated land site or a demolition site. And when we undertake far source monitoring and high volume sampling, the high volume sample as an improved limit of quantification. Now, in terms of the technical meaning of a limit of quantification, this is basically the lowest concentration possible for a test determined by that procedure and the accuracy and precision of the test. And again, I'll go on to explain that perhaps in a bit more detail on the next slide. So in HSD 248, there's a table that recommends different types of samples. If you just focus on the static sampling at the bottom here, there's a whole raft of tests that we undertake as air analysts that are what we call standard tests. The clearance testing after a 4-stage clearance, asbestos removal, backgrounding leak testing, and general reassurance monitoring. All these standard tests have a limit of quantification of 0.01. This means this is the lowest level that we can report on our certificates. Okay, and this is because we have a volume set at 480 litres, and we count 200 graticules on the filter. Now, a graticule is a circular area, and again, I'll show you some examples of that in a few more slides. However, you notice here for fast source monitoring, we are taking a larger volume of sample, still counting the same number of graticules on the filter, but we're getting a much lower level to report to, down to 205 there. So what we can do in terms of air monitoring is increase the volume of air and or increase the number of graticules that we count on the filter to get a lower level limit to report to. So when we have the background levels within buildings at 305, can we realistically get down to those sorts of levels? But before I answer that, let me just discuss the phase contrast microscope techniques. So PCM has been about for many years. It was developed in the sort of 60s and 70s, primarily for the monitoring of exposure for asbestos workers and for sort of removal operatives. And clearly these scenarios, they're expecting to find asbestos fibres. So PCM testing was the ideal technique to use. It is quick, it is mobile, and you can get a result at the right in the right place at the right time. So air analysts will set up their equipment on site, typically a microscope and some pumps. They can undertake the monitoring on site and count the filters on site and provide a result there and then. There's no need to send the samples away for analysis to another lab, etc. So this is the standard technique in the UK, and typically it is cheaper than the other lab-based techniques I mentioned earlier, such as SEM or TEM. However, as I've alluded to, use of PCM does have some disadvantages. Again, it is purely a total fibre count, and there's no fibre discrimination. So therefore, if we're using this sort of technique in sort of general occupied buildings, there is a risk that we're going to pick up non-asbestos fibres and count those fibres. So we do need to be careful about what we're counting. Like I say, for the standard test at 480 litres and counting 200 fields, we only get down to 0.01 levels. Therefore, if the guidance from HSE is to reduce exposure as far as feasibly practicable, how do we get down to these much lower levels? Okay. Just to kind of clarify and give you a flavour for what our analysts will see on a filter through an air monitoring and air testing. This is a typical example of a slide that's been mounted. They count inside the circular graticule, this circle area here, and all these shapes around the outside in numbers indicate fibre sizes that we deemed a countable fibre in terms of the counting rules that we work to. When we look inside the circle, we can clearly see some straight dark fibres here, one there, another one over here. There's probably one stuck behind that piece of dust there as well. Those are most probably likely to be amosite fibres. So this was a slide taken on an asbestos removal project, removing amosite asbestos. We've also got this fibre on this side, this kind of bright fluorescent fibre. It's probably not asbestos, but would need to be counted on that air test based on its size of dimensions. So here we have a slide that's 5 fibres counted. The other thing to bear in mind is that all these specks you can see around this filter, the slide, are bits of dust. The problem we need to be aware of that when we undertake high volume sampling, is that there's a risk of loading dust onto the filter that would obscure and cover the fibres. So there is a careful trade-off to be had when we're undertaking high volume sampling, that we do not end up with dust-loaded samples. But the question is then, where can we undertake high volume sampling, and when should we undertake it? Why would we do it? So one obvious example is, outdoors. Okay, so contaminated landslides, asbestos in soils, etc. On these sorts of sites, there are often asbestos that have been buried historically. That material degrades over time, and the fibres literally become free. And when the work is undertaken on the soil, there's the potential for the fibres to become airborne and released into the air. We can undertake air monitoring on site in terms of far source boundary monitoring by running pumps for long durations, and therefore achieving lower limits of lower level of resorts. Okay, so again, a very good way of using high volume sampling. How would we do this? Typically on other projects, what equipment do we use? Historically, the problem with air sampling pumps is that they would only last for perhaps 2-3 hours at any one time. Therefore, any long duration sampling would need to recharge pumps. With the improvement in battery technology, there are now pumps that can run all day long on one charge. And we are currently working on a very large project where there's historical asbestos contamination on site, and there is the risk of the spread of that asbestos around this very large site. And we've been on site now for many months undertaking outdoor air monitoring, but also undertaking indoor air monitoring for longer durations. And we've set up air sampling techniques whereby we're monitoring for at least 6 hours indoors at 10 litres a minute, counting 500 of the fields on the filter, and achieving a limit of quantification down to 0.0005, 305. And also when we're outside doing boundary monitoring, again, running the pumps for a longer duration, 8.5 hours at a higher volume, 16 litres a minute, and counting more fields, we're able to get a limit of quantification down to 302. So it is possible to undertake high volume sampling and achieve much lower limits of quantification compared to the standard clearance indicator test of 0.01. So that's actually sampling outdoors and indoors. What kind of scenarios might be suitable for this type of monitoring, and why would we want to do it? A couple of classic examples here of scenarios we come across quite often. Contaminated sealing voids, with chunks of AIB, or contaminated boiler rooms with residues on walls, etc. Would it be suitable to be running high volume tests in these sorts of situations? I would probably start by saying probably not. We probably shouldn't be doing that. What we should be doing is using Regulation 4 and managing that risk by either isolating these areas, restricting access, preventing people from being exposed, and putting a abatement program to remedy that situation at some point in the future. If taking some air tests to confirm that the area is below 0.01 or much lower, it's probably not going to cause or not going to prevent anyone from being exposed. In these sorts of scenarios, Regulation 4, duty to manage, you must manage that risk accordingly. What about a scenario whereby you have a building with lots of asbestos insulating board? Again, a classic example: ceiling tiles throughout the building, throughout the room, and over some point in the past, there's been some works, small amounts of damage done to the AIB boards historically. That's long gone. What is the level of air fibre in this area? Is it above 0.01? Is it significantly below 0.01? You could run a standard air test for at 480 litres, and the chances are, yes, you would get a result probably below, or hopefully below 0.01. But is that going to be low enough? Does that meet the requirements of the ACOP in paragraph 453? That requirement to fibre levels are at an acceptable environmental level. If that environmental level is 305, then clearly running a high volume air test in these sorts of areas would get down to 305 and either confirm that the levels are acceptable environmentally, or maybe they're slightly elevated. Okay. So then, really to summarise, and where can we undertake high volume sampling? There are sort of several scenarios. The building type could be a key factor. So class buildings are buildings that were constructed in the 1950s to 1980s, prefab steel frame buildings, and these buildings were often built with lots of asbestos insulating board within the structure of the steel work. And of course, historically, it's difficult to access these buildings to actually identify the AIB. So doing a high volume sampling in these sorts of buildings could be a benefit. Clearly, after an asbestos incident or accident where there's been a disturbance of asbestos, and that's then being cleaned up, undertaking reassurance post-cleaning air sampling, a week later, 2 weeks later, again to confirm if fibre levels have fallen down towards an environmental level. You could also use it in terms of assessing the potential spread from one site to another or from one building to another. And this is similar to what we're undertaking currently on this site. We've got staff working, undertaking high volume sampling. If there's a change to the building use or building occupancy, again, vacant buildings that become occupied, increased risk of movement through the building, disturbance of materials. Again, another scenario that you could use high volume sampling on. Then the last couple there, obviously concealed ACMs, very similar to the first one. Areas where there's ACMs in areas that are difficult to re-inspect on an annual basis as part of your Regulation 4 duty to manage. Could that be supported by high volume sampling to confirm that fibre levels are as low as possible? And then we've got unusual conditions. We've had the recent storms in January and February. Lots of buildings that were losing roofs, etc., or disturbance of buildings. Again, is there the potential for asbestos to have been disturbed during these storms and to have released fibres into the buildings? So there's various scenarios that we could use high volume sampling on. What would you do about the resort? But clearly, any resort above 0.1 would indicate that there's a need to stop and investigate, because that's above the clearance indicator. Resorts down to 3.05 or less clearly indicates the site is well managed and the asbestos risks are therefore low. And again, if you get resorts between the clearance indicator and the 3.05 environmental sort of level, then clearly we can sort of trend monitor those limits. Are those levels coming down? Are they increasing as things change in the building that perhaps are causing the increase or decrease? I suppose the key message here is, is to investigate and not to panic. We're not going to say use high volume sampling and therefore we need to start removing asbestos left, right, and centre. It's all about managing that risk and having another tool in the asbestos management armoury to demonstrate best practice in terms of managing that asbestos risk. So just to kind of summarise, we really do need to consider why we're going to be doing high volume sampling. It's not going to be suitable for all scenarios, but it can obviously be undertaken to achieve results closer to background levels. And clearly, it's going to provide reassurance that fibre levels are not elevated. And what I probably need to touch on now really is just to say that it does need to be a combined sampling strategy. So we are going to use our standard PCM techniques, measuring all total fibre, but we would also complement that with fibre discrimination using SEM, a scanning electron microscope, whereby perhaps one sample is sent for fibre discrimination, and we can produce reports that have all the information on, and clearly sampling high volumes of air, high number of fields, and getting down to very low levels of fibre detection to give that reassurance that the level of fibre within the building is significantly below the 0.01 clearance indicator, and thereby down to environmental levels as suggested by the approved code of practice. Just to wrap up then, with my crystal ball, what does the future hold? Well, there's been quite a lot of movement within the UK and the EU recently in terms of asbestos management. We wait for sort of years for things to happen, and then we get 248 issued. And then at the start of this year, there was the UK government parliamentary inquiry into how the Health and Safety Executive managed asbestos in the UK, and looking over the past sort of 20 years. I suppose the upshot of this is that there's going to be very little change going forward. I think that's the main message. But that said, in Europe they use SEM and TM for fibre monitoring. That's their standard technique. So in Europe, they're able to fibre to discriminate on their air tests. And clearly, there's a cost implication and time implication. But clearly, that's a technique that's routinely used over in Europe. Again, the UK government parliamentary inquiry, HC are not going to probably budge in terms of changing the techniques in the UK currently. When we look at the EU, they're going to lower the clearance indicator to 0.001, again, a factor of 10 times lower. And again, from the parliamentary inquiry, the HSC gave no indication of any change in the UK going forward. So going forward, UK clearance indicator will still be 0.01 fibres per centimetre cubed. And then in Europe, they're more proactive at removing asbestos. So the Netherlands are in the process of removing all their asbestos cement sheets by 2024, which is a very tight deadline. And the Flemish government has recently announced a new asbestos policy to remove all their asbestos by 2040. And again, excuse me. And again, looking at the parliamentary inquiry, the HC again gave no indication of any change of tact in terms of asbestos removal. The message from the HC is still, manage the risk and remove asbestos when it becomes a risk. There's at the moment unlikely to be any kind of phased removal of asbestos in the UK from the HSE. So therefore, to conclude, then, there's going to be very little change in terms of asbestos management from the HSE in terms of guidance. But buildings are getting older. The ACMs in these buildings have been in place for probably 50 plus years. So AIB, lagging, etc., has been about 50 plus years, and is starting to approach its end of lifespan. Asbestos materials will deteriorate in the coming years. Yeah, no planned phase removal in the UK. Therefore, is now the time to approach to air monitoring to support ongoing asbestos management, perhaps away from the standard 0.01 fibres per mil clearance indicator test to a more lower level in terms of ongoing reassurances for the next sort of 10, 20, 30 years to demonstrate, best practice in terms of asbestos management. I hope that you found that interesting, and we now have an opportunity to answer any of your questions that you may have. Okay, so like I say, thanks for your time this morning. Again, if you get any questions, then by all means contact me at matthew.harris@socotec.com. Like I said, I can answer those queries or contact another member of our team. Thanks for your time, and I hope you found that useful. And I will say goodbye.